This is moles and Stoich review number 3. We're going to review balancing equations and how to do mole-to-mole problems. In order to balance an equation, we need to have the same number of atoms on each side. And this is because of the law of conservation. The law of conservation of matter, the law of conservation of energy tells us that nothing can be created or destroyed. Things will just change forms. So in order to agree with that, our balanced equations need to have the same number of atoms on each side to show that nothing was created or destroyed. When a reaction is correctly balanced, all things will be conserved. And the things that will be conserved will be matter, energy, and charge. Sometimes they say mass, energy, and charge. What we're going to do first is remember that the arrow is like an equal sign. So this arrow says that everything on each side has to be equal. We will make a tally for each element on each side before the reaction happens. And before the reaction happens, I have 2 hydrogens on the left, 2 hydrogens on the right, 2 oxygens on the left, and only 1 oxygen on the right. I'm going to use a coefficient in front of the compound where the oxygen is on the right in order to get 2 oxygens on the right, but that also multiplies by the hydrogens and makes the hydrogens go up to 4. So now my oxygens are balanced, but my hydrogens are out of balance. I'm going to use another coefficient and put it in front of where the hydrogen is on the left, which multiplies by the 2, making 4 hydrogens on the left as well. So now I also have 4 hydrogens on each side, which means that this reaction is balanced. If I want to know what the coefficient of the oxygen is, the coefficient of the oxygen will be a 1. Anytime there is no coefficient, it is an understood 1. If you are given a mole problem, it will read something like, how many moles of something if this many moles of something else? You have to use a balanced equation. In order to be able to answer these questions. So if the question says how many moles of oxygen will be required to react with 5 moles of hydrogen, the first thing is that we're going to use how many and represent that with an X. Because it said how many moles of oxygen, I'm going to put the X over the coefficient of oxygen in the balanced equation. Then it says will be required to react with 5 moles of hydrogen. So because it says 5 moles of hydrogen, I'm going to put a 5 in my numerator, and I'm going to put that over the coefficient for the hydrogen in the balanced equation, which is a 2. I now have my proportion that I can solve. X over 1 equals 5 over 2. 2x equals 5, which means that x equals 2.5 moles, which makes sense because in the balanced equation, the ratio of coefficients of hydrogen to oxygen is 2 to 1, which means that if we're going to use 5 moles of hydrogen, it has to be 5 to x would be the ratio, which has to be equal to a 2 to 1 ratio. Again, if 5 to x has to equal 2 to 1, x has to equal 2.5 moles.